Alrighty, so here we go. So again, we're going to do like I said. So we're going to be constructing a line parallel to a given line. Actually, parallel or perpendicular. We're going to do both. Okay? Constructing a line parallel or perpendicular to a given line and through a given point. Okay. So let me just show you that here. All right, so what do I mean by that? Well, let's say we've got a line. Okay, using my straight edge here, I'll just draw a line. And we'll call this like, I'm going to use the single letter name for it, so I'll just call it like line L. Okay, single line, line L. And let's take a point not on that line, L. And we'll call that point P. Okay, P for point. And what we want to be able to do now is to draw a line parallel to L that goes through P. Draw a line parallel to line L that goes through point P. Okay. We want to do that with our construction tools here. Okay, we want to do that with our construction tools here. So, I'm going to show you the steps. Okay, and then we'll kind of stop and discuss about why that works, why it works. Okay. First thing we're going to do is take our point P and our straight edge here, and we're just going to draw another line that goes through P and intersects our line L. So, I don't know, something like this. Okay, I may need to extend that just a little bit. Okay. It doesn't matter where it intersects line L really. I always tend to like have it intersect like to the left of point P. And I'll just draw another little point right here. Okay. Now, I just created a little line right there that I drew using a straight edge, point P and a point on line L. I also created this angle right here. Okay. I also created this angle right here, and this angle right here. I guess this obtuse angle here, this angle here, and this angle here. But we're going to focus on this angle right here. Okay. And what we're going to do from here is basically the copy and angle construction. Okay, it's that simple. We're just going to take this angle that I drew a little arrow in here. We're going to take this angle, we're going to copy this angle up to here so that its vertex is now at point P. All right, the vertex of this angle right here, I don't know, we can call it like point A or something like that. This point A, the vertex of the angle here, we're going to move it up to have the vertex here at point P. We're going to copy it. So, copying of an angle, right? We remember that. You take your compass, okay, and then you swipe so that you hit both sides of your angle. And if you need to, you can turn your paper. If you don't want to have to like turn your compass, you can just turn the paper. We'll do the same swipe up here at point P, right? Same kind of swipe. Okay. Same kind of swipe. Right? If your arc from point P doesn't intersect the side, then extend it. You can use your straight edge to extend the side if you need to there, so that the arc intersects it. Okay, but that's what we've got. All right. So far, so good? Questions on anything? So this first arc that we drew created these 2 points. 1, 2. Okay, created those 2 points. This point, the top point here, it's already got a match right here, right? There it is. It's kind of in my G, but there it is. Okay, so I already have this point. It's right up here. I need to come up with this point. Where does it go on this arc here, right? This point right here, where is it on this arc? Well, like we did before, right, we'll measure the distance between these 2. And then mark it off. Okay, so again, measure the distance between those 2. Mark it off, and then we'll do the same measurement up here. Okay, it's a bit different. Normally we are copying our angle from like this side and we swipe up to there, but now since we have this side already, we're swiping from that point down here where they crisscross. All right. And then where those 2 arcs intersect, we'll put a point and then draw, using our straight edge, and there's our pair of parallel lines. Okay, I'm going to put the little arrows on them to show that they are in fact parallel. Okay. All right. Questions on that? Anyone having trouble? Avery, question?
Are you like measuring the distance? What was the last distance you measured?
So the last thing, so you have the arc here and the arc here. You have this arc and this arc.
Yeah.
Okay. So then, just like in the past, we have, so this point has its match up here. This point right here has its match up here. We need to figure out where this point was, and so you're going to measure from this point to this point right here. Compass point there, measure to there, and swipe. And you're going to pick your compass up and do the same thing here. Compass point there, measure to here, and swipe. Don't measure. You'll use that measurement to swipe it and stuff. Does that help?
Yeah.
Okay. All right, voila, parallel lines that went through a given point. By copying this angle, well, first of all, remember we started with this line and this point P. We drew a line through that point P to our line L, okay, which created this angle. We then copied this angle to here so that they were congruent. What's the name of this special angle relationship right here? This pair of angles, I should say. They are what? Corresponding. Exactly right. So what we're doing, excuse me, is like the reverse of what we've been doing. Okay? Before, we started with 2 parallel lines crossed by a transversal, and we said, aha, since these 2 parallel lines are crossed by a transversal, that means corresponding angles are congruent. Now we went backwards. We started with a line, and we made a transversal through that point P. Okay? We then copied this angle so that corresponding angles are congruent. Since the corresponding angles were congruent, we then said, aha, these 2 lines are now parallel. So we went backwards. Normally, we start with the fact that the 2 lines are parallel, we start with the fact that 2 lines are parallel, and that allows us to say corresponding angles are congruent. But we can also go in the reverse, and that will help us as well. We can also start with corresponding angles when you have 2 lines crossed by a transversal. That then guarantees that those 2 lines are parallel. So these 2 lines, we've constructed them to be parallel. Okay? Of course, some of you might look at your line and say, Ms. Widmeyer, I'm pretty sure if we extended these lines, they would eventually intersect. And like, yeah, that's a matter of imprecision with your compass and straight edge and stuff like that. Okay, but if we construct it accurately, it would make parallel lines. Okay, questions on any of that? All right, so that's probably like one of the toughest constructions you'll have to do, okay, right? The next one we're going to look at, so I guess I should name this. This is, well, I guess you have the directions there, but parallel through a point. I guess I'll say that as like a brief. Okay, and so now we'll do perpendicular through a point down here. So again, for this one, we'll start with a line. Okay, and I'll put a point P. Not on that line. Again, I'll call it line L, I guess. Again, not very creative. Okay. Now, this is a bit different, right? Before our point P, okay, was just kind of out in space, and we just kind of connected P to our other line willy-nilly. Because we didn't really care about how P connects to L. We wanted a parallel line through P. Here, though, we do care about how P connects to L. Because the line that goes through P, okay, has to be perpendicular to line L. Okay? So I can't just like willy-nilly connect P to line L. I need P to be perpendicular to line L. How are we going to do that? Well, we're going to start with our compass, and we're going to put our compass point on point P, the only point that we have there. Okay, and you're going to open your compass point up. Let me see if I can get this light to help some. You're going to open your compass point so that it goes beyond line L there. Because we want to intersect line L. Okay, so you see that I'm on point P, and I'm going to intersect line L, and I'm just going to swipe, and I should be able to do it so that I hit line L twice. Once kind of on either side of point P. If you do the full arc, that's okay. Mr. Whitmire, I don't hit line L twice, I only hit line L once. Well, then extend your line L so that you will hit it twice. Okay? Anytime that we intersect an arc with a line, that creates a point for us that we're going to use. So there's our point, there's our point. And I don't know, I'll call this point A and this point B. Now, if I were to measure the distance from P to A, and if I was to measure the distance from P to B, how would those two measurements be related? What's that? They would be equal, Chrissy. Exactly right. I mean, isn't that how we found points A and B in the first place? I used my compass from point P, and my compass didn't open or close at all, so the distance from point P to point B had better be the same as the distance from point P to point A, or else my compass had moved or something like that. So this A and B now, okay, created these 2 points, and I can think of this A and B as like a segment within line L, right? A and B is a segment within line L. And P is an equal distance from A as it is to B. And so, like, if I were to kind of move P straight down, it would intersect that line L. And if I were to move point B straight down to my line here, what would point B for segment AB? It would be the midpoint. Yeah, it's the midpoint. Okay, P is exactly halfway between A and B right now. So how can I draw this perpendicular? Well, I'm going to use points A and B, and we're going to do the perpendicular bisector construction, right? I made this segment so that P is in the middle. So it's going to be one of the it's going to be on the bisector. So all I got to do now is from point B, make sure I'm open up more than halfway, and do the football. And then from point A, make sure that I'm more than halfway, and do the football. Okay, and then those 2 swipes, connect them using your straight edge, or the swipes intersect, I should say. And there we've created a line P sorry, not line P, a line perpendicular to line L that goes through point P. Okay? So it's basically just one more step before the perpendicular bisector construction. It's one step previous to that. Okay? The main construction, though, of this perpendicular through a point is the perpendicular bisector construction. The main construction for parallel through a point is the angle copy and angle construction. Okay? So I'll say like, that's 1 and that's 2. Right, what we did there basically. 1 swipe from P. And then 2 perpendicular bisector of segment AB. Okay, here, step 1, connect P to L. And then step 2, copy angle to point P. So that maybe will help guide you some too. Again, I said here, connect P to line L, right? And then copy the angle here to point P there. So it looks, I guess maybe I should do it more like this. This would make more sense if I do it that way. Like that. Okay? That's all it is. So it's just like an extension of copying an angle for this one, and this is an extension of perpendicular bisector. Question?
What is the first one?
Mm-hmm. Connect P to L. Connect P to L, right? Because initially P is off of line L, and then you just draw a line through point P to line L there somewhere. And then copy that angle that you made to point P. Okay? So there you go. Constructions. That covers the majority of the constructions that we're going to be working with so far in this class. Bless you, we're going to look at maybe a little bit more in the future, but those are the basic ones we want to have down for right now. Okay? All right, can I move it? All right, so like I said, I also want to talk about some theorems here too. Okay? I'm going to try and make this as easy as I can, so bear with me here. I think I have an idea about how I can organize it and save you guys some writing. Okay. So we'll call this proving lines parallel. If you want to continue on with from your notes from the constructions there, that's fine. Okay. We'll call this proving lines parallel. Okay. First of all, I'm going to talk about the word converse and what it means. Okay, yes, I know it's a shoe company, but it has a meaning in logic too. Okay. Logic is built, most of logic is built on these, or the way you make a logical argument is built on these things called conditional statements. If A, then B, right? We said in the past, if two lines crossed by a transversal are parallel, then corresponding angles are congruent. Or, if you have a right triangle, then leg squared plus leg squared equals hypotenuse squared, right? That's Pythagorean theorem, okay? Most theorems can be broken down into if-then statements, but most proofs are really an if-then kind of statement. The logical flow kind of thing, okay? The converse of a statement takes the order and flips it, okay? So again, like we said before, if two parallel lines are crossed by a transversal, then corresponding angles are congruent. I guess that's for you guys, it's more like this than this maybe. That, for the converse, that flips around, and we can say, if two corresponding angles are congruent, then parallel lines. You have parallel lines, Okay, that's the idea. So the converse takes an original statement. This is not like super official definition, but it's the idea. Takes an original statement, if A, then B, and says, if B, then A. If the original statement is true, must a converse always be true too? Okay, and if you think not, can you give me a counterexample? So, Madison, what do you say?
If A is greater than B, but B is not greater.
Okay. If A is greater than B, then will B be greater than A? Okay. Avery, what were you thinking?
I was thinking like, if there's a square, then it is a rectangle. It's not always if there is a rectangle, then it is a square.
Yeah, and that was the example that I was thinking about too, right? So sometimes you have things that like fit into a broader category, right? For example, you know, if you are a female, then you, well, I don't want to say, if you are a girl, then you're a human. I guess not, because you could call girl other animals girls too. Well, how about this? If you are a human, then you are an animal. True statement, right? If you are an animal, then you are a human. Not necessarily, right? Because there are other animals besides humans and things. So converses don't always hold true, but they can. It just sometimes you have to prove the opposite direction. We won't be proving the converses of these. Sigh of relief, right? So here's what I'm going to kind of do here. I'm going to make like a little flow chart thing to help us. So if corresponding angles I guess I do the ... Alternate interior, I'm going to abbreviate that one. Alternate exterior. Co-interior angles. Okay. And then actually, I don't need the ... dots there. Okay, so I try to save some writing here. Okay, so I made like a little flow chart. Okay. Okay, and this saves us having to write a little bit more than we need to. If corresponding angles are congruent, then the two lines crossed by the transversal are parallel. If alternate interior angles or alternate exterior angles are congruent, then the two lines crossed by the transversal are parallel. If co-interior angles are supplementary, then the two lines crossed by the transversal are parallel. Okay. These are the converses of those, of the corresponding angles, alternate interior angles, alternate exterior angles, and the same side or co-interior angles theorems. Okay, these are the converses of those things. So we don't know the lines are parallel. How can we prove they're parallel? Well, if you see a pair of of corresponding angles that are congruent, or a pair of alternate interior or a pair of alternate exterior angles, if they're congruent, then you know that the two lines are parallel. If you see a pair of co-interior angles are supplementary, then you know that they're parallel. Okay, so let me show you some examples here. Our directions are to determine whether A is parallel to B and justify. Okay, determine whether A is parallel to B, justify. Number one, let's draw a picture here. Am I going too fast? Do I need to slow down? We're good? Okay. Okay. Notice, I am not marking A and B parallel, right? We are, in this case, we're trying to determine whether A must be parallel to B using given information. Okay, so let me run us through this one. Let me run us through this one here. Okay, now, looking at this, all right, I see that we can't immediately connect 127 and 53 degrees. That's not one of our special angle pairs, right? They're not corresponding, they're not alternate interior, they're not alternate exterior, and they're not co-interior. So I need to do some work here, all right? What I can do is something like this. I can see, aha, this 53 degrees, it's vertical to this angle, so I can say this is 53 degrees as well. But that's not really helpful, because again, I don't have this angle to match with it. But I could also say, for example, that this angle is vertical to the 127, and say it's 127 degrees. Okay. I then can show, well, 53 plus 127, these two angles are co-interior, and they add up to 180 degrees. So we can say, for example, A is parallel to B because same side interior angles are supplementary. Okay? That's our justification. Okay. Yes,
Can
Avery.
we call those coexterior angles?
I mean, I see what you're saying, and like, yes, we could. We haven't like done the theorem for it or whatever. I don't know if that's actually like I don't know why it's not a thing. It should be a thing, right? If we have co-interior and coexterior. So I mean, yeah, you could think of it that way.
And also, could you do like corresponding angles, like 127 is corresponding to 127?
So yes. So what we could do here, we have to be careful though. We won't use I don't think we would want to use necessarily the 127 unless we need to do one more step before that. Either we would use like the fact that 127 is a linear pair with this angle. We could use the 127 as a linear pair with this angle to get 53, and then say, aha, this 53 corresponds to this 53, and so therefore they would be here. So yes, that way too. Jen?
Couldn't we use the 53 and the 27 as the exterior angles?
The co-exterior or something like that.
No, the 53.
Here? Or this one?
That one, and then the
Say that this is 127.
the other.
This
one
right here?
next to 127 to the right.
This one. Here.
Hi. One more.
Here.
Yeah. Wouldn't that also be 53?
Okay, so here's where we got to be careful. This is 53 degrees, yes. If you're saying this is 53 degrees because it's a linear pair with 127, that's fine. But we can't say that if this is 53, that this must be 53, because now you're using alternate exterior angles, but those are only congruent if the lines are parallel. We haven't shown these lines are parallel yet. You see what I'm saying? So, but, let's just, a subtle change here. Like I said, if this is 127, you could say it's a linear pair with this, which is 53. Since you now see that, 53 is congruent to 53 or equal to 53, now they must be parallel kind of thing. But we don't want to use alternate exterior angles relationship there because they're not parallel yet, right? So you don't want to use what you're trying to prove in order to do the problem. Let me show you a better example of that maybe in this next one here, number 2. Okay? Because this is a common thing that students can get hung up on here a little bit. I'm going to throw in some variables here. And again, I'll say there's line A and there's line B. Okay, now it gets a little bit funky because we've got x's. All right? I've got a pair of corresponding angles right there. I've got a pair of corresponding angles, but do I know if they're equal or not? No, we don't. Okay? We don't. Because we don't have, these lines are parallel just yet, and we don't know what the x value is. Okay? So, we do need to set up an equation here, but we can't just set it up willy-nilly. Okay? And what I mean by that, that's kind of a silly thing to say, but whatever. What I mean by that is that this 3x plus 15, right now, we don't know if it equals 60 degrees. But Mr. Whitmire, they're corresponding angles. Yes, you're right, they are corresponding, but these lines aren't parallel. We're trying to show they're parallel. So we can't set these two things equal because we don't know if they're equal or not. But what two things must be equal that does not depend on parallel lines here? Jake? Why must these be equal? They're vertical. Do vertical angles require that you have parallel lines? No. So this will always be true, and that's why we're going to start. Our equation must say 4x minus 20 equals 60. That's where we have to start there. Okay? So we'll solve. I get x is 20. Are we done with the problem? Have we shown whether A is parallel to B or not? All we've solved for is x. But how is this going to help us? Madison? Plug x in here and plug x in here. This x they're talking about is the same x value. So we can plug it in here. 4 times 20 minus 20. Okay, so it's going to be 80 minus 20, so 60 degrees. So this angle right here is 60 degrees. Which shouldn't surprise us because, well, it's vertical to this 60-degree angle there. But anyway, okay? This angle right here, 3 times 20, 60, plus 15, 75 degrees. Emma, question? Sure. No, you're welcome. I'm sorry. Okay. Are these two lines parallel? No. Why not? Go ahead, Avery.
Corresponding angles are not congruent or alternate exterior.
Yeah, either one would be a sufficient argument there. Okay? Corresponding, 60 and 75 are corresponding here, right? Not congruent. Or alternate exterior angle 75 to alternate exterior angle 60. Not congruent. So A is not parallel to B because, and again, you can use either one. I'll just use the alternate exterior because I can abbreviate that easier. Because alternate exterior angles are not congruent. Okay. Your work here is kind of your justification, but you need to indicate this here too. Okay. A is not parallel to B. You've answered the question, but then because. Why? Exterior angles are not congruent. All right. Let me give 2 here for you to try. So you guys are going to try 2 here, okay? And then we'll be done. Same directions. Try to show that A is parallel to B. Okay. So go ahead. If you finish both of these and you're feeling good, or you don't want to like waste any more time, if you want to like get right into tonight's homework, that's fine. The homework is on Google Classroom. We'll, if you want, and then we'll go over this. So don't, I wouldn't put this too far away. But if you like finish these up and you're feeling good about them, you want to like get into the homework, it is on Google Classroom if you want to get started on it. Okay. It's going to be both papers there. So, but we'll go over this here too in just a few minutes. Question? Okay. Yeah, go ahead. Okay. Then I'd say, yeah, there's still, yeah, I'd say so.
And then we don't have to look at that.
No, that's right, it's excused, so you can just take the point for it. That's fine, that's fine. Again, for number 4 there, think about which lines you're trying to show are parallel. Okay? You're not trying to show that all lines are parallel, you're just trying to show that A is parallel to B. Only trying to show that A is parallel to B. You don't really care about the other two that are there. Okay, so yeah, see? Yeah. Yeah. So it's gonna be both. It's gonna be both. Yeah, whatever one is like appropriate for that particular one. Yep. So you could use that, yeah. That's an idea, yeah.
So which one's on?
It's gonna be both of them. It's gonna be both. It's good, just so I can get you some time here. Anyone still need more time with number 3? Anyone still working on number 3? Okay, so number 3 is A parallel to B. No, no, okay. So one way we could do this is what I kind of showed you before, right? 2x plus 70, we can't say that's equal to 2x plus 80 just yet because, again, we don't know that A and B are parallel, so we can't say the corresponding angles are congruent. But we can set that 2x plus 70 equal to the 120 because they have to be congruent, they're vertical. Subtract the 70 from both sides, and you're going to get 50 here, and then divide by 2, x is 25. When you plug that 25 in, here you're going to get 170 degrees. Here you're going to get 180 degrees. Are they parallel? No. Okay. Let's see. You could say corresponding angles are not congruent. Now, when I was walking around, Jake said, Mr. Widd, do we even have to show work here? Jake, why didn't we really even need to show work here? Can you explain that?
Because if the lines were parallel, then the two equations for the corresponding angles would be the same.
Right. Is it possible for 2 times a number plus 70, is it possible for 2 times a number plus 70 to be the exact same value as 2 times that same number, but now plus 80? It's impossible, right? Impossible. So you can even look at that one without even calculating to see, no way. How about number 4? Are A and B parallel? Are A and B parallel? Here's A, here's B, crossed by a transversal. 60 and that 122, what should they add up to? Yeah, they add to 182. They should add to 180. So A and B are not parallel. These two as well, right? This is a transversal crossing A and B. 120 plus 58. Yeah, 178, not 180. So A and B are not parallel. However, if we talk about these two lines here, if I call them maybe like C and D, they are parallel. 120 and 60 out of 180, 58 and 122 out of 180. So C is parallel to D. Okay, co-interior angles are congruent or supplementary. Okay, something like that. All right. Questions on any of that? All right. Your homework doesn't have a lot to do with these. It's got some more like angles and stuff for you to figure out. Okay, I've got some more proof practice and then an angle paper there for you too. Okay, so it's gonna be. I would like you to do both of those things. I'd like you to do both those things. I know I didn't leave you very much time. I apologize. But I would like you to do both of those things, okay? Try and do as much of those proofs as you can, okay? It's a front and a back, okay, 3 proofs. And then here you've got some angles to figure out, the lettered angles, right? So you can see like there's A, there's H. You can see you have some parallel lines here and there and stuff like that, so use those to help you. And there's a few angles down there for you to figure out too, okay? So try those both, please. Okay, again, they're all in the Google Classroom. You gotta get going. We'll see you, Brandon.